Today we're talking about congruent triangles and being able to identify the corresponding parts of congruent triangles. So our essential question today is, how do I identify the corresponding parts of congruent triangles and then use that information to write congruence statements. So a couple things about the vocabulary. First of all, corresponding means matching. Congruent means the same measure. And congruent and congruence are just different forms of the same word. So how do I write a statement proving that two things are congruent? It's called the congruence statement, and it just has to do with being able to identify how they're labeled. So congruent triangles are triangles that are the same shape and size. They have to be both. Each triangle has 3 sides and 3 angles. If all 6 of those parts, of the corresponding parts of 2 triangles, are congruent, then the triangles are congruent. So when we look at the picture below, all those symbols indicate parts that are congruent. So I have angle A and angle E. So there's one angle. Angle B is listed as congruent to angle F, and angle C is congruent to angle G. So there's 3 of my 6 corresponding parts. Then I look at my sides, because I can have 2 triangles with the same angles that are different sizes. So then I have to look at, are all 3 sides, so AB matches EF, BC matches FG, and CA matches BE. So because of that, then I can say that triangle ABC is congruent to triangle EFG. We're going to list all of the corresponding parts. I can say that angle A is congruent. This is the symbol for congruent. It's a equal sign with like an NA accent over it. So angle A is congruent to angle E. Angle B is congruent to angle F. And angle C is congruent to angle G. Notice that I went from the left to the right triangle for all of my statements. You want to keep that same order and pattern as we go through this process. So when I'm looking at corresponding congruent sides, I want to say that AB, the line over it, is congruent to EF. Notice that AB goes from top to bottom and EF goes to top to bottom. It's not FE, it's EF. BC segment is congruent to FG segment, and side CA is congruent to side, not angle, side GE. Remember that in math we can't just say that 2 things are congruent or equal or similar or any other definition without having some sort of proof. And that proof comes from one of the following statements. Either I can say that 2 triangles are congruent if their parts are congruent, So if I can prove that all the parts are congruent, then I can say the triangles are congruent. Or if I know the triangles are congruent, then I know the parts are. So corresponding parts of congruent triangles are congruent. So if I know the triangles are congruent, then I know all the parts are. And we abbreviate that justification with CPCTC, because you have to be able to justify why you say that things are congruent. Let's come down here and look at some of our examples. The first one starts with triangle RKO. R matches D, so that's the first letter that I have to look at. Then I started with K, so here's K. K matches M. And then I have O, which matches E. I can't write it any other way. I can't say DEM, MED, any of those kind of things. It has to be in the same order. Triangle WBZ is congruent to triangle. Let's start here. W is between the 1 and the 2. So the one that's between the 1 and the 2 over here, 1 and 2, is P. Then we look at B. B is between the 2 and the 3, so that's S. And then the last letter is C. Triangle ADC, ADC is congruent to triangle BDC. All we're focusing on is the order and making sure that they match. For the next two, this is that CPCTC. Except I spelled it wrong. CPCTC. These are congruent triangles. I'm telling you they are. Now I want you to identify the parts that are congruent because the triangles are congruent. So we start with angle V. These are also vertical angles. That's another way that we would know that they were congruent. And then we look at angle U and M. That leaves W and N. Then we go look at the sides. VU and VM, VW and MN, and then WV and NV. Again, I'm telling you that these two triangles are congruent. So your job is to identify the pieces that means. So Q is congruent to L. R is congruent to M. And that leaves S congruent to N. Sides, QR and LM, QR and LM, RS and MN, and then SQ and NL. Remember that it's not direction as much as order that allows us to say what we're trying to match. So I have triangle GH. That means that my other triangle, I go from 1 to right to 2, so 1, right, 2 is triangle FEI. Angle EFI matches GFH. Side FG goes from 1 mark to right angle, so to go from 1 mark to right angle this way is FE. EF would be incorrect. Angle G matches angle E. Side GH matches side EI. Angle H matches angle I. And side FH matches FI. When we look at number 8, there's no picture to go through. So I need to be able to do this without a picture. So when we start with angle ACR, then that matches EGO. Side AC matches EG. Notice that I'm just getting this based on the order of the triangle names. Angle A matches angle E. Side RA matches side OE. Angle R matches angle O. And CR matches GO. For triangle EFI, notice that the letters are in the same thing, so this is going to just be angle GFH. FI matches FH. FIE matches FHG. IE matches HG. Angle E matches angle G. And side FE matches FG. So the important thing about this is the order in which you label things, because order is what matters most in naming congruent parts of congruent triangles.